Good evening, all. This is Anupama, and today we are going to discuss about the electrostatics in this live session. Good evening, all. Right. So today we are going to discuss about the electrostatics and the importance of electrostatics in the application of in physics and all that, right? So we will start in a couple of minutes. Let everyone join the class, and then we start this. Yes. Okay. Okay. Let's begin this. Um. Yes. Okay, let's begin this. Yeah. So, as I told you, today we are going to learn about electrostatics, and this is Anupama. You are going to see this YouTube video or YouTube session through the Spark Academy. Okay. Um, yeah. Yes. This is Anupama, as I told you, and today you are going to learn about electrostatics or static electricity, whatever. Right. Uh, So you are going to view this YouTube session through the Spark Academy. You can join live for all the classes, free live classes every day through our YouTube session. And then here you can see we have, online coaching and daily live classes we have, and you can also clear your doubts, free material in our app, and tips and tricks, and previous year questions also. This all questions also you can see in our app, right? Admissions are open for classroom teaching online and offline too. So you can just download our Spark Academy app in the Play Store, and then you can view what all are the courses they are offering, right? So these are the live sessions you can see here. Monday to Friday, every day you will have live sessions, right? And 6 to 7 you can view my live classes in the YouTube, the physics by me in the YouTube Spark Academy YouTube class. Okay. You can use my coupon. I mean, to get the discount, you can use my coupon code ANU10 in the Spark Academy app, and then you can get discounts. Yes. So today, as I told you, we are going to study about electrostatics. Electrostatics is an important chapter, and the weightage for this in all the competitive exams you can get 6% to 8%. Usually last year to 2021 question paper, we have got 6% in the MSET, and 6% in the, I mean, 7% in the NEET also. Okay, right. So as I told you, total electricity is divided into two types. One is current electricity, which we have been learning through our earlier YouTube sessions, and this is about the static electricity. Static electricity is all about those charges which are stationary, the charges which will not move, which are stationary, right? That is about the static electricity. Okay, charges which are stationary, meaning these charges, the stationary charges, will be developed on the surface of the body, any body. It's not compulsory that it should be an insulator or a conductor. Any body if you take, and by electrification process, we will discuss that. By the electrification process, you can just charge a body, maybe positive or maybe negative, by charge a body. And to test the charges, you can bring any another charged body, and then you can see if it is repelling or attracting, then definitely the body has got charge, right? So as I told you, like unlike current electricity we have seen only about those charges which were passing through from one place to another place through the conductor, means one point to another point of the conductor, right? Whereas here in static electricity, it's not like that. When you electrify, like when you give charges to anybody, the charges will be present on the surface of the body. For example, how do you charge? The charging process takes place in three different ways, and the process of giving charges to any body is called as electrification. So what is electrification? is friction? Rubbing is called as friction. Means if you rub any two bodies, any two surfaces, then one body gets charged. Like very good example for this is like when you rub your hands, two of your hands, then due to friction the heat is developed. That is one process of producing friction, or so here what happens is in this case, in the case of electrostatics, when you are combing your hair with a comb, then what happens here is after some time the comb gets charged. Okay, when you comb your hair continuously, especially the dry hair, and bring that comb near to the pieces of paper, lighter pieces of paper, then the comb attracts the pieces of paper, right? So this particular thing tells us that the comb gets charged. Here the comb is an insulator, the plastic material, and it is an insulator. We all know that, right? So it gets heat, it gets charged. Okay, this particular test attracting and all proves that it is charged. That is one way of charging. And second way of charging is induction. Induction is a process of inducing the charges onto the other body. Like when you are bringing two different bodies, one is charged and one is not charged, and bring near to it, place near to it, due to the induction process, the other one also gets charged, right? That is one thing. And second thing is conduction. In conduction, we are going to use two conductors. One is earthen, where that conductor gets charged from the earth, and then another one is placed near to it, and due to the conduction process, the charges are just flows from the charged body, which is actually earthen, to the uncharged body, and the uncharged body gets charged, right? So this is how electrification process takes place. And as we are learning about the charges, the charge is nothing but it is of two types. One is the positive charge and other one is the negative charge, right? And it is represented by Q, and the unit of charge is Coulomb. Definitely the mass of the body changes when you are charging, okay? And also it depends upon the charge, whether it is positive or negative, that also impacts a lot. And the charge Q is also given as N into E, where N is the number of charges present on the charged body, and E is the charge of an electron or a proton here, which is given by 1.6 into 10 power minus 19 coulombs. If it is a positive charge, that is a proton, it will be positive, and if it is an electron, it will be negative, right? So this is how a body is electrified, and a body is described in terms of charges. Okay, right. So the next one is, this is all about the charge, right? Now, as I told you, electrification is done and the body is charged actually, right? So when the body is charged, what happens here? What happens to the charged body? How the charges are spread on the body? That is very, very important, right? How the charges are spread? The charges are spread on a body depending upon the shape of the body. Like if you are taking a circular body, like spherical body, and then you are charging it. You are giving charge to it. Then how these charges will spread on that particular sphere? It just spreads on the particular sphere in that particular shape only. Like how liquid takes the shape of the container. Same way, even here also, the charges spreads on the body depending upon the shape of the body. Right? So, the number of charges which are present per unit mass is charge density. And depending upon the shape of the body, there are different types of charge densities. Now we will learn about those charge densities. right? The charge density is nothing but the number of charges which are spread on the volume of, shape of that particular body, right? This is the charge density, and there are three different types. Like we have three different shaped bodies, like one dimension, two dimension, and three dimension. In the same way, in the same way, these charged bodies are charge density is also divided into three types. One is the linear charged body, linear charge density. Okay. Linear charge density, which is represented by lambda. Okay. And linear charge density, and then lambda is given by Q by L, meaning the spreading of charges linearly on a long rod. Okay, so that is about the linear charge density. So in YouTube session lo na mali vastadi. So the unit of lambda is Coulomb per meter. Coulomb per meter is the linear charge density lambda, right? And then next one we have surface charge density. Surface charge density is represented by sigma. Sigma is equals to Q by A, meaning area wise it is distributed. That is surface charge density, and this is equals to, unit of this is equals to Coulomb per meter square. This is surface charge density. And then next we have a volume charge density. Volume charge density is represented by rho. Rho is equals to Q by V. Okay, charge distributed per volume. Q is nothing but Coulomb by volume is meter cube. Coulomb per meter cube is the unit of volume charge density, which is represented by rho, right? Surface charge density sigma, volume charge density rho, and linear charge density lambda. I think you might have got the difference between all these three, isn't it? What is that? Linear charge density is all about the spreading of the charges lengthwise, linearly, right? And surface charge density is the spreading of the charges area wise. If you take a two-dimensional thing, then which consists of length and breadth, or any circular disc which consists of area, then area wise whatever charge is distributed, that is surface charge density. And the next one is volume charge density, which is represented by rho. Okay. Rho is the volume charge density where the charges are distributed per unit volume, right? Yeah. So this is about the charge densities. And next we have Coulombs Law. We call this as Coulombs inverse square law. According to Coulombs inverse square law, Coulombs inverse square law is all about, force acting between two charges. Already we have discussed this, right? When two charges are brought nearby, then there exists a force of attraction or force of repulsion in between the two charges, right? So this is about this force Coulombs inverse square law says, right? According to Coulombs inverse square law, the force acting between two charges, for example, I am taking Q1 or Q2, maybe, they are at a distance of R or D, right? Two charges which are separated by a distance of R. Then the force acting between these two charges is directly proportional to the product of the charges, right? They are proportional to the product of the charges and directly proportional to the product of the charges, and it is inversely proportional to the square of the distance between them, right? This is inversely proportional. The force acting is inversely proportional to the square of the distance between them, right? So if you combine these two, you get F proportional to Q1 Q2 by R square, right? If you take out the proportionality, you get a constant which is represented by K into Q1 Q2 by R square. That meaning what? This particular relation tells us that when the distance is when two charges are close to each other, then obviously the force acting between the two charges will be greater, right? If R is small, F is greater. If R is bigger, meaning two charges are far away from each other, then F is less, right? This is how the force is described here, right? So F is equals to K Q1 Q2 by R square is the force which we got from Coulombs inverse square law, right? Now what is this K here? K is a constant which is represented by 1 by 4 pi epsilon naught, which is equals to numerically equal to 9 into 10 power 9. Okay, anyways, I'll tell you the units of this actually. So the value of 1 by 4 pi epsilon naught is, the magnitude of it is 9 into 10 power 9. Okay, so what are the units of it and what is this epsilon naught? That we will learn. Okay, so this is about, I'll tell you what is K and all that, right? So, okay. So, this is about the K constant, 1 by 4 pi epsilon naught and all that, right? So, anyways, this is about the force acting between the two charges according to Coulombs inverse square law. Why we are calling it as, by the way, why we are calling it as Coulombs inverse square law? Because this force which is acting is actually inversely proportional to square of the distance between them. That's why we are calling it as Coulombs inverse square law. And you are watching this particular YouTube session through the Spark Academy's YouTube app. You can download the app. Just go to the Play Store, download the app, and then you can see this is how the Spark Academy app looks like. Already I told you. In the app, if you want to register to any of the courses, you can use the code ANU10 and you can use my code and get the amazing discounts which are offered by Spark Academy. And once you download it, then you can see here all these things, the free handwritten notes, free study materials, previous year question papers, and the free mock tests. Right? So there will be link in the description and you can just click on the link. Okay? You can buy any of the courses which are offered here. There are long-term courses, crash courses, mock tests, previous year solutions, full length test study materials, all these high quality courses you can get with great offers and discounts. But how? You have to use the code ANU10, right? You use the my code and get the great discounts which are offered by the Spark Academy. Okay, and we have online and offline coaching. Classroom coaching consists of short-term coaching, regular coaching. You know what is the difference between short-term, regular, and crash course, right? Okay, so yeah, this is how this is what they are offering. Uh, Classroom coaching, short-term coaching, regular coaching, and very soon we are going to start the crash course. Crash course at Naranguda and also at Mehdipatnam. Okay, we have two branches, Naranguda and Mehdipatnam. Right? All these courses are available in both the branches, Naranguda and Mehdipatnam branches. Okay. Right. So online coaching is also available. This is NEET 2022 online coaching, JEE Mains 2022 online coaching, EAMCET 2022 online coaching. All online coaching is also available here, and as I told you, you can use my code, that is ANUZ10. By using this coupon code, you will ANU10, you will get greater discounts in the Spark Academy app, right? So, and what does the app consist of? The app consists of all these, like you can see the videos, right? Assignments, daily assignments will be there that will be posted online in the app. Those all are visible, right? And then, yeah. Yes, videos are also available. Even if you miss one day, you can attend those. Videos which are in the store. At any time, and all these are available in the app, right? Yes, and then yeah, as I told you, assignments will be posted every day, and then every weekend test will be there. Test will also be posted online, and then these are the test details and all that, right? This analysis after the test, the result will be declared in the app itself. See how advantageous, how good this is. Okay. What are our methodologies? The basic concepts, right? We start teaching with the basic concept because base is very, very important. If you lay the foundation, good foundation, then you can construct many floors. That is how it is, right? So basics are very important. So usually we start teaching with the basics. Shortcut methods, that is also very important for last minute preparation. All model questions, exercise questions, okay, and model questions will be discussed, exercise questions also will be discussed, and previous year questions, chapter wise tests we can test, brand test and test analysis. I told you just now analysis will be shown like that. So all these may be there in other academies also, but why only Spark Academy? Okay, highly experienced faculty. You can see in the first page all the faculties are shown, right? Personalized coaching, process oriented coaching, personal mentoring and doubt clarification, limited batch size. Okay, we don't put hundreds in one batch. Okay, limited batch size. These are the advantages if you select Spark Academy. And how? Just go to the Play Store, download the Spark Academy app, click on the link, and you will get all the courses which are available. If you want to buy any course, use my code ANU10 for great offers and discounts. Right? So what are the features? Access to classroom, yes. Access to classroom, hybrid coaching, yes. Online classroom, it is not available. Access to online, both hybrid and online coaching, both it is available. Books, hybrid coaching, that is offline coaching, it is available. Online coaching, we'll just send the PDF, that's it. Online study material in both the cases. In Spark Academy app, you can see weekly tests, yes, whether it is offline or online, weekly tests will be there. Grand test will be there whether it is offline or online. Doubt clarification in person will be there if you opt for offline coaching. Online mode also doubt clarifications can be done. Right? So this is about the Spark Academy, and the advantages of choosing Spark Academy. Okay. Right. So where we stopped at f is equals to k into q1 q2 by r square, right? Okay, and anyways, as this is the force, what do you call this force to be? Electrostatic force, right? And the units of any force, it is Newton only. Newton in SI system and dynes in CGS system, right? Now from this formula, I told you, right? K is equals to 1 by 4 pi epsilon naught is equals to 9 into 10 power 9, right? So what are the units of K? Now let us take this formula. We get K is equals to F into R square by Q1 Q2. This is unit of F is Newton, R square is meter square, for Q1 Q2 is Coulomb square, right? So Newton meter square per Coulomb square is the unit of K, right? Now what is this epsilon naught here? What is this epsilon naught? Epsilon naught is a constant, permeability constant, permittivity constant, and this can vary from, this is actually epsilon naught, we said this is in the free space, okay. So in the space where there is medium, epsilon value changes, and then we can relate in the free space and in the space which are in the space both by relating with a formula, that is relative permittivity, that is epsilon naught is equals to epsilon r is equals to epsilon by epsilon naught, right? So this is about this value. Okay, now let us find out what actually this force describes. What does this force describes here? The force is an electrostatic force, and this describes about the of the attraction or repulsion between the two charges which are placed at a distance r from each other. Okay, so this is about the electrostatic force, right? Now, what actually describes means, like, there will be force from first charge onto the second charge. Both will be attracting or both will be repelling, isn't it? So, in the vector form, if I have to write Coulombs law in the vector form, how can I write? Coulombs law in the vector form. Like, let us suppose this is Q1, Q2, and one is positive and other one is negative, for example, then attraction definitely will be there, because like charges repel and unlike charges attracts, right? So the force will be there from the first body on to the second body, right? And in the same way, equally, in the opposite direction, second body also exerts force on the first body. Means this, when you take direction into consideration, then this is how Coulomb's inverse square law can be written in the vector form, because the force from the first body onto the second body, in the same way, opposite direction, the force from the second body onto the first body. Then how will you write this? F12, that is force on the second body from the first body, is equals to, same way, like 1 by 4 pi epsilon naught Q1 Q2 by R square as it is, into the unit vector R, R21 in the reverse direction. Obviously the distance is measured from this, right? What is the formula for unit vector here? This is R bar by magnitude of R. Put this here. Then what you will get? F12 is equals to, I'll just write K Q1 Q2 by R square into R bar by magnitude of R. Right? Then next what you will get here? So, F12 is equals to K into Q1 Q2 by R square into R21 bar. This will be R magnitude, no? This will be R cube. So, this is how we can write F12, the force on the second body from the first body, by using the Coulomb's vector method. Coulomb's inverse square law in the vector form. Then the reverse side, it will be K into Q1 Q2 by R cube into R1, reverse side. Both will be magnitude wise, both will be same, but direction wise both will be acting in the opposite direction, right? So this is the Coulomb's inverse square law in the vector form. Next we have principle of superposition. Principle of superposition, right? Okay. So according to principle of superposition, when two or more bodies, two or more charges are surrounded by a charge like this. Let us suppose this is Q and this is Q1, Q2, Q3, Q4 and so on, right? Then according to principle of superposition, the total net charge acting on this charge, the net force acting on this charge which is placed in the middle and surrounded by these many charges is equals to sum of all the forces. That means the net force which is equals to, I can write F1 plus F2 plus F3 plus so on, right? Then it will be F1. F1 I can write as K into Q1 by R square plus F2 is K into Q2 by R square, so on, right? If you take K by R square common, K into Q into R square common, by R square common, then it will be Q1 plus Q2 plus Q3 plus so on. So in this way, the total net force can be found out on a charge which is placed or which is surrounded by n number of charges around it. This particular principle is called as principle of superposition of the force. Okay. So this is all about the electrostatics up to the principle of superposition. Means till now whatever we have learned about electrostatic force. This is only the beginning of electrostatics. Now we are going to explore more and more, like we have electric field here and we have electric potential, capacitance, and then dipole, torque, and many more things are coming up in electrostatics, right? So many things are there to learn in electrostatics. This is only the first part. So in the second part, you will see few problems which are related to the force, that is, which are related to the Coulombs force, right, in the vector form, or if it is not in the vector form also. How will you find out the force acting between two charges? That we will learn in the next session, and then followed by electric field. Okay, so this is about the charges, right? Yeah, we have Spark Academy also have the Telegram group. So you can just click on this link, just go to Telegram page and then type Spark Academy online. You can see our Telegram and follow the Telegram for many more things. Let us all explore by knowing the new things, right? So this is about the Spark Academy Telegram page, right? And then, we also offer JEE, NEET, EAMCET, IIT Foundation for IIT 9 and 10. You know how important IIT Foundation is in the school level, right? Those who learn foundation courses in the school level, and then, who are strong in their basics, then it will be very much helpful for them when they enter into the junior colleges, right? Foundation plays a major role nowadays. Every school is offering these foundation courses, right? So we have the best foundation course in the Spark Academy. You can just join even in the foundation also, or refer to your friends who are really interested, right? So as I told you, just explore our page, go to the Play Store, just download the Spark Academy app, and then you will be seeing all these things. Whatever you want to buy, just use my code ANU10 to get the greater discount. So this is all about this session, and this is Anupama, physics lecturer. Today you have learned about the electrostatic force, only about the force. Tomorrow in the next session, we will continue learning how to solve the simple problems for these electrostatic forces, and then we will also learn electric field in the next session, right? So these are our results. Actually result speaks result speaks more than anything else. So these are our results. We have got the excellent results and excellent background. So by seeing our results, you can understand, like, how benefited it will be if you choose Spark Academy. Right? These are our students who have got this is the number who have got selections for MBBS medical entrance tests in the last years, right? So this is about the Spark Academy live session and electrostatic signing off. This is Anupama, and I hope this particular session is useful for you. Thank you all for joining this YouTube session of Spark Academy today with me, and tomorrow in the next session we will continue with the problems which are involved in the force, in solving electrostatic force, and also we continue with the electric field. Until